We live inside a galaxy so large that our brains struggle to process its true scale. But that exact same vastness creates a harsh physical reality. We are completely isolated. Look at our closest galactic neighbor, the Andromeda Galaxy. It is 2.5 million light-years away. If we found a perfect, habitable planet there, our current technology makes it totally unreachable. If you boarded an advanced spacecraft today, traveling at 28,000 kilometers per hour, it would take you 94.5 billion years to cross that gap. Even if you engineered a ship to travel at the absolute speed of light, you'd still travel for 2.5 million years before you arrived. These distances form a physical boundary. Unless we find hidden mathematical loopholes in the laws of physics, humanity will eventually die right here in the Milky Way. That search for a loophole starts with Albert Einstein. In his 1915 theory of relativity, he introduced a set of equations showing that space is not a void. It is a physical fabric that bends and curves under the weight of massive objects. His math revealed a theoretical shortcut. Folding a 2D plane through a third dimension connects distant points instantly. Applied to our reality, this Einstein-Rosen bridge, or wormhole, bends the fourth dimension, creating a glowing spherical junction between star systems. Opening that junction requires a force strong enough to tear the fabric of space-time. The only thing with enough gravitational power to do that is a black hole. But black holes are one-way systems. They pull everything in and let nothing out. If a wormhole connects two black holes, anything that enters is trapped forever inside the event horizon. Entering a one-way gravitational collapse leaves no way to reach a destination. To move through space-time, the exit point must act as the inverse of a black hole. We need a white hole, a cosmic entity where matter and light can only exit, and nothing can ever enter. Many physicists reject white holes because they seem to violate the second law of thermodynamics. Black holes shred planets and stars, increasing the universe's disorder. A white hole would have to gather that shredded energy back together, lowering the entropy of the system. But Stephen Hawking realized that black holes leak radiation and eventually evaporate. According to quantum physics, information cannot be permanently destroyed. When a black hole dies, the matter it consumed must be accounted for. This leads to the hypothesis that when a black hole reaches the end of its life, it might undergo a quantum bounce, transforming into a white hole to expel everything it ever swallowed. We may have already seen this happen. On June 14, 2006, NASA observatories detected a massive anomaly, designated GRB 060614. It was a brilliant flash lasting 102 seconds. Usually, an explosion of this scale requires a dying star, but there was no evidence of one here. It was a spontaneous ejection of matter and light out of an empty void. Theoretical math is also being tested on Earth. In 2015, scientists at a Spanish laboratory manipulated magnetic fields to build a functioning magnetic wormhole, successfully separating a magnet's poles through an invisible gap. Observing unexplained cosmic expulsions and engineering small-scale magnetic tunnels proves that these concepts are moving towards scientific plausibility. If tearing space-time open is too dangerous, there is a second solution that manipulates the fabric of reality without breaking it. In 1994, physicist Miguel Alcubierre proposed a different solution to Einstein's equations, the Alcubierre warp drive. This math suggests a spaceship doesn't move at all. Instead, it remains stationary while heavily compressing space-time directly in front of it. By simultaneously expanding space-time behind it, you create a rolling wave. The ship stays inside a bubble while reality slides past. You aren't violating the universe's speed limit because the ship isn't moving. You are bypassing the limit by moving the fabric of space-time instead of the craft. Today, wormholes, white holes, and warp drives are mathematical solutions to a century-old set of equations. Back in 1916, black holes were also considered to be a mathematical impossibility. It took 103 years for technology to catch up to that math. In 2019, humanity captured the first photograph of a black hole, proving that these equations eventually yield observable reality. These solutions serve as a technical map for manipulating the physical laws that currently restrict us. Engineering the curvature of spacetime would dismantle the physical isolation of our solar system. At that point, the edges of the Milky Way become a threshold for exploration rather than a permanent limit.